So I just want to know before starting my talk, like how many of you have already heard about server components? Okay, and do you think you understand them well and why they are, or do you still confused about this topic? Okay, because in my talk I will start with the basic and go up to try to explain to you as much as I can why server components are here and what are the motivations behind them and what solutions they are trying to solve. So before we start, just a quick introduction about me. I'm a software engineer, so I'm based in Paris, and I work a lot with JavaScript, TypeScript, React. I do also some mobile development with React Native. So these are the languages I speak, and I'm pretty. I like the ecosystem, and as Matthew said, React is something we love, and sadly we can't quit. Yeah, so I also try to create content like on part-time. So I'm not too much consistent, but you can find me on all social media accounts using my full name. So in this presentation, I will try to explain first, like go with the basics, reminding you what are client-side rendering and server-side rendering, and then we will go through the React server components architecture, and I will try to explain the advantages and limitations of them alongside with a quick live demo, and lastly the current state of today of React server components. So we all know that React revolutionized the web development, and its popularity mainly lay about their components-based architecture, which we saw in the previous talk. Like many libraries and packages are inspiring from React components-based architecture, because like they make the web development more modular, efficient, and scalable. So quick recap of client-side rendering. So this strategy like mainly lies first when the user will try to initiate a request by clicking a link or entering a URL. So the server will try to respond by sending a minimal HTML file with the necessary JavaScript. So the browser then will try to download this JavaScript and execute React, which will take over and do all the data fetching and requests from APIs. And finally, the browser will render the full page interactive to the user. So this is, of course, like good for quick interactions after the initial load, but the initial load like might take longer to show up, especially for large applications. And this introduced us to slow application performance, especially on low-end devices, because we as developers, we can't control like the devices our users use, and also like on the network like speed, we can't control these things because they are on the end user. So the server-side rendering was introduced then to solve this problem. So if we try to compare it with client-side rendering, is that the user will do the same, try to click on a link and request a URL. The server will receive that request and start processing. So they will do all the necessary data fetching from databases or APIs. And the server will run React to generate the HTML with these data, and will send us to the browser a static pre-rendered HTML, which immediately will display it, as we can see on the bottom. And then simultaneously, the browser will keep downloading the JavaScript necessary. And finally, we have the hydration process, which will occur to attach all the event handlers to the static pre-rendered HTML to make the page interactive. So the key difference here is that the server does the initial render and will send the complete HTML document to the browser, while we will have the second step, which is the hydration that will attach all the event listeners to that static HTML. So this approach will like solve the problem of initial page load, because we will have first like something to display to the user, and we can claim that it's better for SEO. But using server-side rendering with plain React was very hard, because it requires a lot of heavy setup a Node.js server, and do a lot of config to use SSR alone with React. That's why a lot of frameworks came up to implement server-side rendering and to simplify using it in React. So at the end, we can say that SSR was introduced to address some of the limitations of client-side rendering in React. So I hope like this quick introduction and reminder was clear. Now I want to talk about server components. So I will try to go deeper in the architecture, so we can always have an idea about what's have been done before and compare them with the actual situation. So React server components, they operate on a fundamental principle, which is the server and client collaboration. So server components basically operates in two ways. So on the server side, we will have our code base where it's hosted on a server, and there we will define all our code, like basic React, we know, components entirely on the server. And then these components will have like access to server-side resources, and they can perform complex computations, and the server will be capable of generating the HTML output of that component. The client side, on the other way, which is on our example, our browser, will receive the pre-rendered HTML of that component and will seamlessly integrate it to the React tree. So in this example, we can have that the server component will have the React component, which will display a simple paragraph with a custom prop name, and then the client will only receive the output. They even like don't have an idea if Word was a prop or not. And what's great about server components is they use like the same familiar syntax we are used to. So for example, this code snippet shows like we have an asynchronous function which will fetch the data from a blog post. And then we have like the JSX that will render our article, and by getting like rendering the title and the body of that article. So this is like we can see that the data fetching could be done on the server using server components. And the client, which is the browser, will only receive the output. So here we have like it's plain HTML without any React specific attributes. And we can like see directly all the output without having any idea about the logic behind of it. So this approach will help to reduce the amount of JavaScript sent to the client and improve the initial load time and overall performance. But you may be asking like how this works under the hood. So we said that server components are exclusively executed on the server, and they can do all the computations and heavy lifting. So when we are processing a request, so instead of sending like the HTML directly, which is this one, we actually send in a JSON format representation of the React DOM tree. So the server will execute our component, and the actual HTML format will be sent to the client in this format, which is this serialized JSON format, which use markers like typeof to identify like React elements, and include like all the other types, props, and children information. And then so the client will receive this data, will try to deserialize this into the virtual DOM, and renders the actual elements of the DOM. So this lets us think of the separations of concerns between the responsibilities of the server, which will execute the components and serialize the HTML into a JSON format, and the client which will receive this JSON format, deserialize it, and then like render it in the actual DOM of React. So as a recap, server components run only on the server. So we only get the output on the client. We don't get any JavaScript. And the second point, emphasizes that since server components are running our own server, we can actually control over the execution time and try to optimize their environment and do all the security measures. And lastly, since these components are running on the server and we only send the output, so basically they have no idea about what's happening on the client, and basically they don't manage any interactive state, and they don't have any idea about what you are typing and doing on the browser side. So you might have a question like, what's happening to all the React code we already used to know and to write? So we can say that the old way of doing React are considered as client components because the JavaScript is handled on the client side, and we have all the interactivity we are used to in React applications. And now, since you want to learn about server components and utilize both of them, so server components are using the familiar syntax we already know, but to define client components and to benefit from the rich interactivity of the client, you can just add this directive, which is use client, on the top of your file. So whenever you are defining a new component and you need states or hooks or any kind of information about what's happening on the browser, you can just use this declarative at the beginning of your file. And you may be asking how server components can work with client components and coexist in the same React page. So this is a quick illustration from the React team that shows the end goal of how modern React application will look like. We will have on the top of the tree, the parent or the root will be a server component, and then it branches to a mix of server and client components depending on your needs. So this structure will allow us developers to decide which components can be run on the server and which components could be run on the client. So since we said that server components will return their output, so after reconstructing the React tree on the browser, we will have the server components that are after the deserialization of JSON, they will be shown on the browser as HTML tags, and then the client components are actually sent as a module reference objects. So each client component will try to download its own JavaScript on the client and do the execution. And yeah, so at the end we will have this tree on the browser. The server, if we start from the beginning, the server will send the whole tree as a JSON format to the client, and the client side will try to reconstruct this tree. Server components are replaced with the HTML tags, and they remain as it is. And the client components are actually model references, and they will be replaced after executing their code on the client. So we can, and at the end, we will have a hydration process, which will happen only on the client components. So server components, since they are not changing, we already have their output. There will be no hydration process for them, and the hydration process of the whole tree will happen only on the client components. So this is the same example of the tree, an actual example, which is like a simple blog post. We can have the page, which is the root of our tree, which is a server component. The posts and the comments section, since they are not personalized to the user, and we already know the data is not changing depending on the user, they can be a server component. And especially we are fetching the data of posts and comments. But if we have a comment section with toggle to open the comments, or a button to like or reply or something, so these interactions need to be client components. Yeah, so this is the same example as before, a component, a React tree with a mix of client and server components. So now let's move on to why do we need server components, which basically refers to the advantages of why they were introduced and the motivations of the React team behind creating them. So the list I'm going to produce here is from the request for comments document. So when React team shared their proposal about this new thing, they shared like the couple of motivations behind them. So I'm trying to list them here and explain them one by one. So if you remember well, we said that SSR was introduced to reduce the bundle size sent to the client comparing to client-side rendering, but we still need to send some JavaScript to the client using SSR. So the first motivation behind like server components is try to have a zero bundle size component. And what I mean by that is by rendering all the complex components on the server only, the client will receive only the pre-rendered static HTML. So all the heavy computations and burden that was made on the user devices will be done on the server. Of course, this is very practical and beneficial for low-end devices with limited CPU and network. And also, like you may use like a lot of server dependencies. So this is very useful because since you do everything on the server, you don't need to send like bundles of your packages that the client will not necessarily need on the payload. So this means that the libraries or modules used on the server-side logic will not contribute to the client download size of the JavaScript bundle. The second thing, or the second motivation behind creating this, is the full access to the backend. So the creation of server components were motivated by the desire to provide to developers like seamless experience and access to backend resources and capabilities. This includes like accessing to the database, doing database queries directly from components, and to allow developers to interact with server resources from their components without the need of an intermediary API layer. So of course, and since we said that the client will only receive the output, any API keys or sensitive data will be stored on the server, and we will reduce, like this will reduce like a lot of security issues because we can safely access and use these sensitive information without exposing them to the client. Another motivation behind creating server components is client-server waterfalls. So just a quick recap about this concept is, imagine you have a dashboard. So the parent page is like the component A. The dashboard, for example, will have a lot of sections. Let's say we have like the latest messages, this section on the dashboard, which is component B. And inside the latest messages, like we have user IDs and other IDs that we need to fetch. So using client-side rendering, we will not show anything to the user. So when a user requests a dashboard, he will be faced with a blank page because the dashboard will wait for the new the recent messages section to be loaded, and the recent this section will wait for another request, which is, for example, fetching the user IDs and getting the information of each user. So this is a common pattern, which is the client-server waterfall, and it's really with client-side rendering, it really impacted like the initial load time. So with server components, we are like kindly trying to solve this problem by eliminating the cascading client-server requests. So in traditional React, we will like do a lot of API calls. First, we will request the dashboard API route. Then we will find out that we need to request another route. We will do another API call. And lastly, we will find out that the component C need another API route. So we will do like back and forward API calls from the browser. So with server components, we can say that instead of doing all these calls on the client, we can do them on the server, and at the end send only the result. So if I try to explain what's happening in this schema, so bear with me, it's a bit it's a bit bad, but like we have the client section which will try to request the server to for example load our dashboard. The server will try to send to our clients the code of our dashboard. And luckily, this code contains a waterfall. So we will do another request to the server to fetch like the component B. The component B will be received, and then we will find out how we need another API route for the children component C, and the server will reply. So we will keep going back and forward before displaying anything to the user on the browser. So after server components, what will happen is the client will try to request from the server our dashboard page. The dashboard, the server will get the code of our component, which contains the waterfall. So all the back and forwards API calls will be done on the server directly, and at the end we will reply to the client with the final output. So we can say that React server components will help us to avoid all the client-server waterfalls by allowing all the data fetching to be happen on the server side and eliminating the need for these multiple round trips and cascading client-server calls. Now I want to talk about another aspect behind the motivations of creating server components, which is lazy loading. So as you know, lazy loading is a technique where, for example, images and other contents are loaded only when they are necessary. So on scroll, for example, we will not load the images until they are visible. So what's happening on the traditional React is that if you forgot to implement like the lazy loading, as we saw below, all the images will be loaded up front, so even if they are not immediately visible to the user. So this can result into an increase of initial page load size and also the bandwidth consumption. And especially if the images are like on high quality 4K or something like that, they will be downloaded regardless if we need them or not. So another motivation is that we wanted to handle this automatic code splitting with server components without any extra config and manually lazy loading all our components. So you will no longer need to handle this code splitting manually. Instead, like server components are introducing this automatic code splitting at the component level without any extra config. And this feature will like help us to simplify the code management and especially the dependencies by separation the concerns of server code and client output. The last motivation I want to talk about is the abstraction tax. So we all know that React abstractions enable us to use like to define reusable code patterns based on the component architecture we already know about React. So reusable code is good, but it can increase like the bundle size and the runtime costs because JavaScript engines like struggle to optimize all these reusable patterns and abstractions. So we have here a funny image which looks like an emoji, a broken emoji, but this is just an illustration of how a React code look like. Like you have different components and each one will be imported in other components. So this can illustrate the React reusability patterns. And with server components, we can see that all these abstractions will be done on the server. So instead of like the client, the clients will be deconstructing all the JavaScript bundle and like downloading and trying to display the page to the user. We will do everything on the server, and this will help us to optimize, like as I mentioned earlier, the JavaScript bundle sent to the client, because as I mentioned, the abstractions are good, the reusable pattern is good as a developer experience when using React, but it impacted the bundle size of JavaScript. Okay, so I just want to go through the limitations of server components before going through the demo. So first one, as we said, there is no interactions with the client. We have no idea about the client-side context. This includes like states and hooks, event handlers, browser APIs, or even lifecycle methods. And I know we as developers, we may like misuse use effects or hooks or something like that. So we should just put attention that everything that requires an interaction should be done on the client, and they should not be defined as server components, but rather as a client component using that directive of use client. So as a recap, this is a table from the Next.js doc, which tries to compare like the use cases of server components and client components. We can say that for server components, we can access to backend resources directly, and we can use like our sensitive information like API keys or passwords. But of course, we should apply like the best practices while using them. And anything related to interactivity like event listeners, lifecycle methods should be handled as client components. So I just want to do a quick demo, which you can find it on my GitHub account. And it's actually also hosted on Vercel. So this demo will be done using Next.js because as as Matthew said, I think there is an unfair advantage of the Next.js because like there are like some of the React core members are working also on the Next.js framework, so they are basically implementing these features very fast comparing to other frameworks. So yeah, this is like the basic a basic demo of our application, which is like a blog post like we saw previously. And we have here like all the posts, and when clicking on a post, we will have like the post content, the comment section, and I put here a counter which like could simulate a like button or an interaction button. So it's a very ugly demo, but I just want to focus on the core concept we talked about in the presentation. So as we can see, like the home page, which is this one, it's basic. I'll just zoom a bit the code. So as we can see, like the home page will try to render the posts component, and the posts component is will do the fetching of getting all the posts from an API. So this is just some dummy data. And then we have like our component, which will try to display all the posts. And after getting like the posts from the function that will do the fetching, we will try to display them very classic. And then for each postcard, I'm putting a link to go to a unique post page, which is this one. And inside that single post page, I'm trying to fetch the post again of that ID. So I'm just getting the ID here and fetching the single post and getting the comments of that post. And we are just trying to display them here on the UI. So first thing we can notice is this is the same code you are used to write. The components with JSX, nothing special. You can do the fetching on the component directly, and we are like then we are displaying the comment section, which will take as props the comments. So I could like fetch the comments on the comments list component, but I wanted to do all the fetching on my page for demo purposes. And then we have like the comments section, which is also a server component, by the way, because we are just fetching the comments details. And we will have like at the end the counter, which is a client component. So the counter which simulates the like button here, we can see that we are using use state. So this is an interactive component and it requires the use client directive. If I try to delete that use client directive, so we will see that we cannot compile our app because they will say that you are trying to use state which only works on client components, and you need to add to that component the use client directive to be able to use the use state hook on that component. Okay. I want to do another quick demo here to separate the concerns and how server components are working comparing to client components. So I'm just like doing a console log here. So we will have like the first console log, which is on the comment section. The comment section is a server component. So I just like console log this. This should be on the server. And then we have the counter, which is we are trying to console log like the count time. And as we can see here, I will just try to refresh the page. And now I will try to click on the count. We can see that this console log should appear only on the server, but if I try to display the console of the client, which is our browser, we will see that the first console log, which should only be on the server, is not displayed on the browser console log. And when I click on the counter, we will see that all the console logs of the counter are displayed only on the client here. So I will just try to rerun my server to show you because I want to mention an important topic here, which is okay. So I want to highlight another aspect of limitations of server components. The first, the next one is that client components renders on the server and also on the client. Why? Because if we are using server-side rendering with server components, we will find that the component will be also rendered on the server on the initial load, but after that, all the interactions with the client component will be rendered on the client directly. But the server components are only rendered on the server, so that's why we didn't see the second console log on the client. Another limitation, which is which I will try to explain using this schema. So let's say you have this React tree, and you have like client components here, which defined with use client. So when this client component is updating, what happens is we create a client boundary which will own all the children components, and they will all be transformed to client components. And when this parent re-render, all the children will do the same. And this is a problem if we are using like server components, because we don't want to redo the API fetches, or like if we have some sensitive data here on a server component and the parent is a client and re-renders the whole subtree, we will like not benefit at all from all the advantages we said about server components. So And of course, as we mentioned, like server components, we don't want them to re-render. So instead of that, there is a limitation concerning the imports and how you use client components with server components. So instead of calling your server components directly on your client components, you rather need to pass them as a prop or as a children. So this is just a workaround to say that the server components, if they are passed as props or children, will not require to re-render the server-generated content if the parent client component is re-rendered. Let's try to see that in a concrete example. So what I will do, like I will just discount, like try to display the as a label component, and I will try to create a label component here, which will just return like a paragraph with count. Oops, sorry. So this is just label components that I tried to define, and I just replaced the count with these label components. Oops. And now we are trying to import that label component. So nothing special here, but I will do a console log on the label component. And as we can see, for each time I click on the counter, we see that on the client console, we also see the console log of the label, which is supposed to be a server component. So basically, this label is a server component, so I should not be able to see its console log on the client. And that's because this is we imported the server component directly, and each time the counter re-render, its child also re-render. So a basic solution to that will be to define a prop here with like label which would be like, for example, React node. And what I will do is for the counter, I will try to pass it as a prop. Okay. So now make sure to use, we are using that label component. Now I will just clear my, my console. And now each time I click on the like button, for example, we are not exposing that server component to the client. So this is like, as I mentioned, a workaround to like solve this issue. There is another thing that I want to highlight here is like the difference between server-side rendering and server components. The way I remember this is instead of focusing on the server word, try to focus on the last word, which is rendering and components. So to remember the difference between them, the server-side rendering is primarily about rendering the whole page on the initial load on the server and sending the full HTML to the client. While React server components allow us to render just specific components on the server instead of rendering the whole page. So we can say that server-side rendering still requires some JavaScript to handle all the interactivity after the initial load, but server components are rendered on the server and they don't need like JavaScript or client-side implementation. Of course, it's possible to combine them both, and this is like what's have been done recently, which more code bases you can find online. And lastly, I want to talk about like the current state of server components. Like we spoke about limitations, and for new people who are exposed to this topic, we'll find like it's an extra layer of complexity to separate these concerns about the capabilities, what the server should be done, should done, and what the client should do. And of course, like there is the import limitations we have seen. So this are some kind of notes to stay aware of. And lastly, when it comes to the ecosystem of React, we can claim that a lot of libraries are able to integrate server components on the packages. Like, for example, we have Storyblock, Tailwind, Content Layer, and other packages. However, we still have like some libraries like React Query or Material UI that still not supporting like server components. And in order to use them, these packages on your components, you need to add the use client directive. And of course, this is I think the ecosystem will evolve in the future, and this like when using, for example, React Query as a client component, you are also shipping some of the bundles of that package to the client. So that's why, like comparing to the previous packages here, all the packages are rendered on the server, and we are not sending them to the GS bundle. And lastly, like we have the Remix is working on implementing React server components. And lastly, I just want to mention this talk, which is from ReactConf, which is about the possibilities of implementing server components on mobile side. So I highly recommend you to check this talk. It's very amazing to discover the full potential of server components on the mobile side. And lastly, we can say that React is full stack, because we can do all the server actions and the interactions and all the fetching in the component directly without the need of an API layer. And I don't know if it's a good idea or bad. It's opinionated, but that's it for me. And thank you for your attention.
Okay, thank you, Kawtar. I have a lot of questions. Thank you for the question, but
Yeah.
I have to choose just one because we are late. And so, is it possible to integrate server components into an existing React application?
So currently, as I mentioned, as it's an unfair advantage, but to utilize server components, it's currently possible with Next.js. So if your application is on Next.js, you may want to migrate to version 13 plus to be able to use server components. This is the first drawback. The second one is when you want to do this, and once you've done the migration, all your existing components, you need to add like the use client directive, and then start to separate the concerns one by one. Is this really a client component or not? If it's not, you will remove that directive. And the third drawback is maybe you need to rethink your architecture so you can separate the components that need to be server only. Okay. If you have any other questions, like we can have them on the lobby or just reach me on social media.
Yeah, thank you.
Yeah.
Just follow her. Thank you.